So we have discussed what is reduction and what is oxidation. Then the next thing that we have to do is redox reaction. So we can define redox reaction. A reaction in which both oxidation and reduction occurs simultaneously. So such reactions in which both oxidation and reduction occur simultaneously, we call it redox reaction. Okay, let's have a look at examples. The first example is when hydrogen and chlorine both reacts and hydrogen chloride gas is formed. So if we place the oxidation number of all the elements present in the chemical equation, then hydrogen is an element. So what is the oxidation number of hydrogen, Hamza? Here, what is the oxidation number of this? Yes, Hamza?
+1.
No. Yes, Ahmad, can you tell the oxidation number of this hydrogen?
Sir, sorry, +2.
Wrong.
It would be 1.
No. What was the first rule, if you guys recall? The first rule of placing the oxidation number states that, see, if there is an element, then its oxidation number is, yes, what will be its oxidation number? If it's not the compound, it's
Sir, 0.
Okay, so you guys have to keep this every time in your minds, that if there is an element, then its oxidation number is 0. And when that element becomes the part of the compound, then it may have any other oxidation number. So the oxidation number of hydrogen is 0 over here. What will be the oxidation number of chlorine? Yes,
So -1.
I'm talking about this. Yes, Hamza, what is the oxidation number of this chlorine?
Sir, -1, but at Cl2 should do -2.
You have just read the rule I have shown you. It's an element or in compound?
Sir, it's
Sir,
zero.
It's zero
okay, sorry. Okay, sorry.
because it's an element. Now, if we look here on the product side, it's a compound. So in compound, we follow the same rules that we have discussed earlier. So there is no element from group 1, 2, and 3. Then we have a hydrogen. So we are going to put a hydrogen +1 charge. The net charge is 0, right? Then it means that here in this case, the oxidation number of chlorine is going to be -1. Yes, is this understandable to all of you?
Yes, sir.
Yeah.
Okay. Now, if you look over here, hydrogen's oxidation number changes from 0 to +1, which means here oxidation occurs and hydrogen undergoes oxidation. In the same way, when we look at chlorine, its oxidation number falls from 0 to -1, which means reduction occurs. So I can say that it is a redox reaction. Is this clear to all of you?
Yes, sir.
Yes, sir.
Okay. Now, have a look at second equation. In this equation, a hydrochloric acid reacting with the metal magnesium, and we will get the salt and hydrogen. So if we will work on this equation, let's do the work quickly. HCl plus Mg and magnesium chloride plus hydrogen. So on which species there is a zero oxidation number in this equation?
Sir, Mg.
Mg and
H2.
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 Good. Here on the reactant side, there is a HCl. So we know hydrogen is +1 and chlorine is -1. We always put hydrogen before the electronegative elements charge. And before hydrogen, we always place elements from group 1, 2, and 3. Now, here on the left, on the right, in magnesium chloride, magnesium is in group 2, so +2, which means that each chlorine have a -1 oxidation number. Is this clear to all of you?
Yes, sir.
Okay, so here you can easily see that the hydrogen's oxidation number decreases. So it means hydrogen is basically reduced over here. Hydrogen undergo reduction. And if we look at magnesium, it's initially 0 and then it turns to be +2, which means magnesium oxidizes or magnesium undergo oxidation. So it is also a redox reaction. Yes, is this understandable?
Yes, sir.
Yes, Ahmed. Okay. Now have a look at
Yes,
third
sir.
example. Here we have a hydrochloric acid reacting with sodium hydroxide. forming sodium chloride and water. So now if I ask you guys to put the oxidation numbers of each of the element in this equation and then identify which element oxidizes and which element reduces. So do it quickly and then let me know about this equation, okay? Yes, have you guys started working on that equation?
Yes, sir.
Then after this, you have to work on this equation as well. And identify then which element is reduce, undergo reduction, and which element undergo oxidation. Yes, Ahmed, are you done with the first equation?
Sir, I'm a bit confused. I'm sending it to you on WhatsApp.
Okay, do send me. Yes, Ahmed, are you done with the first equation?
I'm doing it, sir.
Okay. Okay, Hamza, very good try. But in water and in sodium chloride, what is the charge of chlorine?
-1?
Yes, -1. You, Hamza, see, you put it +1. I don't know why.
Okay, sir.
Okay, so here chlorine is -1 because it's in the compound and bonded with the hydrogen. Here chlorine is -1. Sodium is in group 1, so it have a +1. Hydrogen is +1. This hydrogen is +1. This oxygen is -2. Here oxygen is -2 and hydrogen is +1 as well. See, is this understandable to both of you?
Yes,
Yes,
sir.
sir.
So is there any element whose oxidation number is increasing or decreasing? Yes. Can you find any element whose oxidation number is either increasing or any element whose oxidation number is decreasing?
No, sir.
No, sir.
No. So it means that it's not a redox reaction. Is this understandable now?
Yes, sir.
Yes, Hamza?
Yes, sir.
Okay. Now try for the second equation now.
Sir, CO2 have -2 charge, right?
Oxygen have a -2 in CO2, right? And there are 2 oxygens.
Okay, fine.
Sir, we won't take Ca before hydrogen or oxygen, right? Or any other reactive element.
Can you repeat?
Sir, we won't take Ca before it's the
CA
rule
is
that
in which
any
group?
hmm
CA is in which group?
Ca is in group 2.
So first we place the charge of Ca, right? Then
Okay.
hydrogen, there is no hydrogen, then most electronegative one, which is oxygen, and at the end carbon.
Okay, sir.
Now have a look over here. Net charge is 0, calcium is +2, oxygen is -2, and there are 3 oxygen, which makes it -6. So the carbon must have a +4 oxidation number, right? Okay, I have received from Hamza. Ahmad, are you done?
Yes, sir.
Hamza, why you are writing it as -6 only? Why you are not mentioning that in charge of individual atom? It will make you confused if you do otherwise.
Okay.
Then how you will going to identify whose element's oxidation number is actually changed? Yes, Hamza, are you done?
Yes, sir.
Okay. Yes, Ahmad, are you done?
Yes, sir.
Okay. So what you identified, which element is undergoing oxidation or which is undergoing reduction?
So carbon is going under, it's losing electrons.
How?
Oh, sorry, losing its oxidation number.
How? If
So
you
it was, yeah.
see here, it's -2. So the calcium would be +2, right?
Yes, yes.
Here it would be
Yes, sir.
-2, but how many oxygen atoms? 2.
2. It would be -4.
So it means carbon will be +4, right?
Yes.
So how carbon's oxidation number is changing? See, carbon's oxidation number is +4 over here and also +4 over here, right?
Sir, oxygen,
Yes, yes.
Yes, see, Hamza, your mistake, you make this -6 and you make this -4. So you can consider it a change. But if you see here, there are 3 oxygen atoms. So one oxygen atom's oxidation number is -2. And here, again, the oxygen number of one oxygen atom is still -2. So there will be no change in the oxidation number in this equation as well.
okay, sir.
So you have to do it like this. Yes, Ahmad, is this clear to you as well?
Yes, sir. Yes, sir.
Okay, great. Yes, Hamza, did you understand?
Yes, sir.
Okay. Now, so we have a few rules to discuss. So you should keep in mind. If you look at the third equation, it's a neutralization, right? Where acid and base reacts to form salt and water, isn't it?
Yes, sir.
So it means you must remember that neutralization is not a redox reaction. So it means if there is any reaction in which acid and base are reacting and forming salt and water, so that reaction is not a redox. Is this clear to all of you?
Yes, sir.
Okay, then
Yes, sir.
if we look at this equation, it's a thermal decomposition. So because why? Because this arrow indicates heat, and on heating it breaks down into a simpler compound. So it's a thermal decomposition of a calcium carbonate, and calcium is a metal. So it means metal carbonate. So in general, we can make another rule that thermal decomposition of metal carbonates is not redox. So it means that, let me write the general equation over here. There is a M, which is a metal, and there is a carbonate, a compound, a metal carbonate. When on heating, it forms metal oxide and carbon dioxide. If you observe any reaction like this, so those reactions are not redox reaction. Okay.
Okay, sir.
Then third, if we talk about double displacement reaction, can any one of you, what is double displacement reaction? Yes, Ahmed, did you know? Double displacement reactions are not redox. So what are double displacement reactions? In which two compounds exchange their ions. For example, there is a compound AB and there is a compound CD. So A and B are the ions in that compound and C and D are the ions in the other compound. So on reaction, what will happen that the ions of these compounds got exchanged normally in a precipitation reaction. So see, the ions just exchange themselves. There is no change in their oxidation number, so it is also a redox reaction. It is also not a redox reaction. Is this clear?
Sir, can you give an example from this double displacement reaction?
Yeah, I will. For example, I have a sodium chloride aqueous. This kind of a reaction you have studied in your O levels or IGCSE, and silver nitrate. Both are aqueous. When we mix them, a sodium nitrate forms, which is aqueous, and a silver chloride forms, which is solid. So it precipitates out, used to make silver chloride. So see, if you put their charges, you will find that none of the elements oxidation number is changed. C. So that nitrate ion is initially with the silver ion, then it bonds with the sodium ion, and the chloride ion, which was initially with the sodium, bonds with the chloride. So these kind of reaction or equations is called redox double displacement reactions, which are also not redox.
Okay, sir.
Yes, Ahmed, did you understand?
Yes, sir.
Okay. Now, what about a combustion reaction? Is it redox or not? Remember, combustion reaction is redox. It is always redox. Because in combustion, we have some substance, and that substance reacts with oxygen, and as a result, the elements which are present in the substance forms oxide. So this is always a redox reaction. In the similar manner, any reaction involving an element on either side of equation is redox reaction. So if you see an element on any of the side and on the other side that element is the part of the compound, then it means it clearly indicates that it is a redox reaction. Okay.
Okay, sir.
If you guys have any confusion, please ask.
No, sir.
Okay. Now, The next thing that we will be discussing over here is oxidizing agent. So we can say a substance which itself undergoes reduction and oxidizes other substance. So these substances are called oxidizing agents. We have an example. The most common example you have studied in your O levels as well is acidified potassium manganate 7. We can write H positive / KMnO4. Here H positive indicates the acidic medium or acidified condition. And when it act as an oxidizing agent, it changes its color from purple to colorless. Another example of an oxidizing agent is acidified potassium dichromate. 6. It can be written as H positive, which shows acidified medium. And remember, instead of H positive, you can write also H3O positive as well. And its formula is K2Cr2O7. So basically the chromate ion in this and the manganate ion in the above will act as a oxidizing agent. So when it acts as oxidizing agent, it changes its color from orange to green. Is this understandable?
Yes, sir.
Okay, you have to remember these two oxidizing agents and their color changes. So when these color changes occur, basically these color changes indicates a redox reaction occurred and the other substance is reducing agent. Is this clear to all of you?
Yes, sir.
Next,
Yes, sir.
reducing agent. A substance which itself undergoes oxidation just give me a minute, please. Okay, oxidation and reduces other substance. The example of most common example of reducing agent is aqueous, potassium, iodide. Its formula is Ki. Aqueous means dissolved in water. Colorless to brown. When it reacts as a reducing agent, itself is a colorless, and on reaction the solution turns brown. So this color change indicates redox reaction occurred and the other substance is reduced, or you can say the other substances basically. Yeah, it is reduced, so it means the other substances oxidizing agent. So now we have understood the one which undergo reduction, which reduces itself is an oxidizing agent, and which oxidizes itself is a reducing agent. Is this clear to all of you?
Yes, sir.
Yes, sir.
Okay. Now, we have a magnesium which is reacting with hydrochloric acid, forming MgCl2, magnesium chloride salt, and hydrogen gas. So if we put the oxidation numbers, we can see that this is magnesium oxidized and the hydrogen ion reduced, right? Okay, so it means that magnesium is sorry. Reducing agent. In the same way, their hydrogen chloride is reduced, so hydrogen ion or hydrogen chloride is oxidizing agent. Is this understandable?
Yes, sir.
Yes, sir.
Okay. Now, this equation for you guys, you have to first identify which substance oxidized, which reduced, then which one is a reducing agent, which one is the oxidizing agent. By marking and indicating all these, WhatsApp me, okay? WhatsApp me, you're working. Okay, I have received from Ahmed. Let me check yours, Ahmed. Hamza, waiting for your.
So I've done the part, but I'm just
Okay. Ahmed, yours is correct. Very good.
Sir, with Cl reduction way and Br oxidation, right?
Very good. So which one is the reducing agent?
Sir, Cl is a Br is a reducing agent.
Can you repeat?
Sir, Cl is a reducing agent, if I'm not wrong.
What Cl is undergoing
No,
oxidation?
sorry, Br is going oxidation, so Br is reducing agent.
Okay, good. So if we put the oxidation numbers, chlorine and bromine over here are 0, and chloride is -1, and bromide is -1 over here, and chloride is -1 over here. So -1 to 0. It's oxidation, and 0 to -1, it's reduction. So it means that chlorine is oxidizing agent, and this bromide ion is reducing agent. Is this understandable to all of you?
Yes, sir.
Yes, sir.
Okay. Now, next we have the rules. That is the last part of redox, that how you will balance a redox equation. So first we are going to discuss the rules for balancing redox equation. So the first point, or the first thing that you have to do, you have to place the oxidation number. Oxidation number of each element in equation. After this, identify the elements whose oxidation number is changing. Number 3, if you have identified the elements whose oxidation number are changes, balance those elements only, not all the elements, just balance those elements only whose oxidation number are changing in the equation. Then fourth, you have to find the change in oxidation number. Okay. So after this fourth, first you have to find the oxidation number change, that what is the change. Then you have to balance the change in oxidation number. It also means that you are balancing electrons. So when the oxidation number change is balanced, then the electrons are also balanced. After this, then balance oxygen by placing H2O balancing oxygen by placing H2O to the side having lesser oxygen. Then seventh, place H positive on the opposite side of H2O. So see the side where you place the H2O, on the opposite side you are going to place hydrogen ions to balance hydrogen atoms, to balance hydrogen in the equation. Then at the end, the net charge on both sides. Must be equal if balanced. So if your equation is balanced correctly, then after this, when you check the charges on both sides of the equation, you will find that both sides have equal number of charges. The net charge will be equal. So it means your equation is balanced correctly. Is this clear?
Yes, sir.
Yes, Ahmed.
Yes, sir.
Okay. So shall we try an equation? MnO4 negative is reacting with iron 2 positive, forming Mn2 positive ion and iron 3 positive ion. So let's have a look at solution. Sorry. So let's have a look at solution. We have MnO4 negative and Fe2 positive arrow, Mn2 positive plus Fe3 positive. So if I start putting the oxidation numbers, I will find it is going to be -2 times 4. And if this oxygen as the net charge is, what is the net charge? -8, right? So the Mn have a net charge of +7. So see, rest of the iron, so we got all the charges. So if you see, let me repeat the equation over here. I have identified the elements whose oxidation number is changing. So Hamza, can you tell me whose oxidation number is changing? Yes, Hamza.
Sir, Mn.
Mn. And
Sir, but Mn +8 नहीं होगा?
no, because it's a negative ion. So there the net charge is -1. And if there is no charge over here, there is no minus over here, then it would be then Mn would be -8. Because we have to get equals to the negative charge, right?
Okay.
Yes, Emma, did you understand this as well?
Yes, sir.
So we know whose the elements whose oxidation number are changing. One is Mn, the other one is? Yes,
Sir,
Fe.
Fe.
Fe. Are there equal number of iron on both the sides?
No, sir.
Why? How many iron ions are over here?
2.
Ions. 2 is its.
Oh, sir, there's one. There's one.
There is one ion. And how many ions are over
Uh,
here?
There's also one.
Also one, so it is balanced. How many Mn ions are over here?
One.
How many Mn are over here?
One.
So it is also balanced. So it means
Yes.
the third step that we have to balance those elements whose oxidation number is changing. We have to skip over here because they are already balanced.
Yes.
Yes, Hamza, did you understand?
Yes, sir.
Now, what is the other thing? The other thing is you have to find the change in oxidation number, right? We have to find the change in oxidation number. So if I'll go for the change is always final minus initial, right?
Yes, sir.
So here it is going to be +3 minus +2. So the change is +1. And here +2 minus +7. So the change is -5. Is this clear?
Yes, sir.
Yes, Ahmed?
Yes, sir.
Okay, what was the next rule? After finding the change, what we will do next? Yes,
Sir, balance the change in oxidation number.
balance the change in oxidation number. Okay, so have a look. Here the change is -5. Here the change is +1. So what I will do, I will multiply this with 5. So if I will multiply this with 5, so it would be +5. Now the change is balanced, -5 and +5. So if I multiply this by 5, it means those species due to which this change is occurring, I have to multiply those species with 5 as well. So it will be like this.
Sir, on both sides.
Yeah, obviously, because both there are two species which due to which this change occurs, right?
Yep, okay.
Yes, Ahmed? Yes, Ahmed, did you understand till here?
Yes.
And for here, I have to just make it minus times 1. So it would be -5. So there is no need to put the charge coefficient before Mn, right? Is this understandable to both of you?
Yes, sir.
Okay. Now, this will be the next case. We have identified the change. We have balanced the change. After this, what we have to do?
Balance oxygen.
Balance oxygen and hydrogen. So here what we did, placing oxidation number and balancing. Here we are going to balance those elements whose oxidation number is changing in this stage. Then here change in oxidation number, then balancing, change in oxidation number, and here balancing hydrogen and oxygen. So to balance the oxygen, we have to put the water on the side where there are lesser high oxygen. So on the left side, we are seeing there are 4 oxygen, and on the right side, there is no oxygen. So I'm going to put a 4H2O. After this, I have to put a 4 hydrogens where there are lesser hydrogen. That is exactly the opposite side of water. So we got 8 hydrogens over there. So I'm going to put 8 H positive over here. Is this understandable?
Yes, sir.
Yes, Ahmed?
Yes, sir.
Okay. Now the equation is balanced. Now I have to check whether my equation is balanced correctly or not. So see, there are 8 hydrogen ions, so each have a +1, so it will be a +8 charge. The 8 hydrogen ions have a net charge of +8. What is the net charge of MnO4? Yes,
Sir, 0.
-1. Why you are
Yeah,
not?
okay, minus.
The net charge on iron 2 positive ion? Yes. Yes, what will be the net charge on iron 2 positive ions? One iron 2 positive have what charge? It's 2+, so there are 5, which makes it +10. Is this clear?
Yes, sir.
Now
Yes, sir.
5 + 2, then 5 times 3 is +15, right? So here if you will add them, what we are going to get a +17. And if I add these, I also get +17. So this indicates that my equation is balanced correctly. Yes, is this clear to all of you?
Sir, but we didn't add 4H2O.
Sorry.
We didn't add 4H2O.
So what is the net charge of 4H2O? Yes. What is the charge on this molecule? Yes, Hamza.
Sir, 0.
0. So whether I write +0 or not, what's the difference?
Okay.
Yes, Ahmad, did you understand?
Yes.
Yes, Hamza, did you understand as well?
Yes, sir.
Okay. So now I'm going to give you one equation. You guys try. And then after solving, WhatsApp me. I'm going to open the previous case. You guys have steps noted down with you, right?
Yes, sir.
The rules. So that is the equation. And you have these steps. Okay, balance this equation quickly, and then WhatsApp me.